Hi, welcome to This is My Architecture. My name is Andrea, and I'm here with Greg from San Diego Gas and Electric. Hi, Greg. Welcome to the show.
Thank you.
What do you guys do?
So I'm an architect in the Digital Innovation Group at SDG&E. SDG&E's mission is to build the cleanest, safest, most reliable energy infrastructure company in America. One of the ways we're doing that is by innovating with emerging technology.
Great. So we're here to discuss intelligent image processing. What is that?
So intelligent image processing, or IIP, is a set of capabilities that helps reduce the risk of wildfire ignitions in California, reduce service interruptions to our customers, and transform our business processes.
Great. And it sits on AWS. So walk us through a flow. Where does it start?
Sure. So we start by bringing imagery from drones and mobile phones mounted in fleet vehicles into S3. S3 acts as a cost-effective storage solution for the terabytes of image data that we bring in. An interesting detail here is we use a vendor partner for capturing our drone imagery, who is also on AWS. We're able to use S3 cross-account replication to easily bring that imagery into our ecosystem.
Oh, interesting. And how many images and what's the frequency?
Yeah, so we have about 4 million images currently in our image repository, and we bring this data in once per day.
Can you walk us through the use case, business use case for this?
Sure. So the key use cases are asset detection, where we're looking for utility assets and images, and damage detection, where we're looking for damages to those assets.
And I do see AI/ML services. So how are these supporting the business use cases you just described?
Sure. So this is where IAP really starts to deliver value. So we first process the images in our S3 bucket using step function workflows.
Okay.
That image processing involves things like resizing, generating thumbnails, and extracting metadata like the capture angle and capture source of the images.
So what's the business logic for the capture source? Can you walk us through that?
Sure. So the capture source is different depending on, or the business logic is different depending on the capture source. So for drones, we have many images taken from many different angles of a known utility asset. For the mobile phones and fleet vehicles, we have images taken from a consistent angle of an unknown asset. So we need some business logic to derive what that asset is.
So how does Rekognition and Lookout for Vision support those use cases?
Yeah, so for the first use case, we have asset detection. The second use case is damage detection. We found that Rekognition works well for detecting large assets, so things like utility poles and cross arms, but it's not so effective for small assets. So in that case, we pass the images from Rekognition to Lookout for Vision, and Lookout for Vision is able to identify small assets in the images, like arresters and bushings.
Oh, interesting. And then where do you store this information?
Yeah, so we write the results out to an S3 bucket from Rekognition and Lookout for Vision, and then we query those results using Athena and combine them with business rules to refine our predictions.
Okay, so let's assume you have a false positive. And how do you address that?
Sure, I'll have to talk a little bit about this flow down here to get there. So what we do is we bring the raw inference results from Athena into Aurora, which is a Postgres database for us and serves as a database for the rest of the application. We then make the data available from Aurora out to knowledgeable end users. The end users are able to identify false positives and false negatives in the predictions, which we then feed back to the model training process.
Okay, and thanks for being here, Greg, and thanks for walking us through the architecture.
Thank you.
And thank you for watching This is My Architecture.